Welcome to this quick dive into matrices, a powerful tool at the heart of mathematics, computer graphics, and data science.
In just 3 minutes, we'll break down what matrices are, how they work, and why they're so useful.
A matrix is simply a rectangular array of numbers arranged in rows and columns. For example, this is a 2x2 matrix. It has 2 rows and 2 columns. A matrix can be composed of any number of rows and any number of columns. We usually denote matrices using capital letters, like A. If we want to reference a specific number within a matrices, we use a lowercase a, and we identify it by its row and column index, where the first letter is the row and the second letter is the column. For example, A12 would mean the number in row 1 and column 2. While a matrice can have any number of rows and any number of columns, there are special types of matrix. For example, a square matrix has the same number of rows or columns. A zero matrix has all zeros. An identity matrix has ones along the diagonal and zeros everywhere else. This is kind of like multiplying by 1. A column matrix contains one column and a number of rows, and a row matrix has one row and a number of columns. A matrix can be transformed through mathematical operations. For example, you can add 2 matrices of the same size by adding their corresponding elements. Similarly, we can multiply a matrix by a scalar number by multiplying each element by that value. Multiplying matrices is a bit different. It combines the rows from the first matrix and the columns from the second. This means that the number of columns in the first must match the number of columns in the second. The summation of the first number in the first row multiplied by the first number in the first column and the second number in the first row and the second number in the first column give us our first value in our new matrix. The pattern continues with the first row being multiplied by all the columns in the second matrix before moving on to the next row in the first matrix and continuing the pattern. This gives us all the values in our final matrix.
In geometry and graphics, matrices transform vectors. They can rotate, scale, or shear shapes. This is why matrices are crucial in computer graphics and machine learning. For example, if we multiply this 2D point against this matrix, we can stretch a shape 3 times wider but keep the height the same. So 1, 2 becomes 3, 2. Similarly, if we multiply a 2D point by this rotation matrix, we can rotate a shape by theta degrees. Matrices aren't just abstract math. They power 3D graphics, GPS systems, spreadsheets, and even neural networks in AI. Anywhere you handle data or transform space, matrices are there. So that's a whirlwind tour of matrices. There are arrays of numbers that let us perform powerful operations, from simple arithmetic to complex transformations. In this lesson, we learned what a matrix is, operations like adding, multiplying, and transforming matrix, and how they're used in everyday applications. Thank you for watching today's video. If you liked the video, make sure to let us know in the comments, and subscribe for more math content.